Good morning, everybody. Today we're going to be starting 11.7, which is adding and subtracting radical expressions. What you learned the last 2 days, you're going to still be using today, but for the first part of the notes, everything's, for the most part, been simplified for you. The thing to keep in mind about these problems is you're not looking for one single answer. We're looking to simplify. We're not looking to really solve. So you might get an answer that has 2 or 3 radicals still left over in the problem. You might not bring them all down to one complete single answer. So all you want to do for these is make sure that you have the same number underneath the radicals. So as long as you have the same radical number, you can combine the numbers that are in front and just keep the same radical. It would be similar to if I give you 2x plus 3x, you would just write 5x. You can add those because they have the same variable of x. If you look up here, you need the same number under the variable. When you add or subtract, don't change the radical. So what that means is on this first problem, I'm not going to add the 3, and the 3 together. They all share a radical 3. My answer will still have radical 3. On this first problem, because all 3 of these have the same radical, all I'm going to do is add up the 3 numbers. So I can think about this as 4 plus 6 is 10. If you want to add the opposite for the 5, you can. That's just going to end up being 5. So 4 plus 6 is 10, minus 5 is 5, so my final answer here is 5 radical 3. If you wanted to show some work, you could underline the first 2 and say that that's 10 radical 3, and then you just subtract the 5 from it. This is your final answer. Next one over here, I have the 12 radical 5 and the minus 8 radical 5. I'm going to underline each one of those once. This has radical 7. I'm going to underline it twice. Same thing with this one, radical 7. Combine the things that have the same number of lines under them. 12 minus 8 would be 4 radical 5. 3 plus 6 would be plus 9 radical 7. I can't combine these because they have 2 different radical numbers, and I can't break down 5 or 7 with my list of perfect squares, so this is going to be my final answer. Also with these, the order doesn't necessarily matter because most of this is going to be multiple choice. You're just looking for the answer that would be in this order. Next problem, same thing. I have something with 11 here, something with just 2 here and here, so 7 minus 6 would be 1 radical 2 or just radical 2. That one in front doesn't matter. I'm going to write that as just radical 2. And then 8 minus 4 would make positive 4 radical 11. And that's it. Really, for the most part, a problem this simple, I'm not going to require work from you because it's already simplified. Next one, these, I've got 2 here and 2 here. I've got 5 here, 5 here. When I go through and solve these, if you notice 4 minus 4 makes 0. Because that means 0 times radical 5, my answer to anything multiplied by 0 is 0. So this is just going to completely disappear. It'd be kind of like writing 0x. 0x means that x disappears. I can still combine the minus 6 and minus 9, which would make negative 15. The nice thing about this is that when I have that negative 15, I don't have to do anything extra with it. I'm allowed to have a negative number in front of a radical. It becomes no solution if the inside number was negative, but we don't have to worry about that. Next one, all of these have the same variable. With a variable, it's the exact same thing. I'm just going to keep those as just x. Also, if you notice, I can't simplify them. The only thing that I have going on is just x, x, and x. Those don't simplify. So I would call this 3 minus 2 is 1. 1 radical x. And then I would drop this one down as plus 1 radical x. So this one's going to end as 2 radical x. This one over here, if you notice, this has just b. This has just b, but this has a 2b. I can't combine these even though they all have the same variable. Everything underneath the radical has to be identical. So if there's a different coefficient, I can't combine them. I can combine these two because they're just b, so 4 plus 3 is going to make 7b. And sorry, that's going to be 7 radical b. This, I can't do anything with it, so it's just going to drop down. I could write that as minus 6 radical 2b, or if I wanted to, I could add the opposite to it and call it plus negative. Doesn't matter. If you notice, for the most part, this is going to be a pretty simple lesson. Down here is what we're going to be looking at if these aren't put in the simplified form for you. So the only thing with these, if I can get this paper to move, you're going to have to do the methods that we did yesterday to make these solvable, but it's not going to be too bad. Um, Remember, you need the same number underneath the radical. Sometimes you can change them all, sometimes you can't. On this first problem, what I would do is, if this were showing my work, I would write this out and I would kind of draw a line down here and solve this one on the side, this one on this side. 27 can be broken down to radical 9 and radical 3. This breaks down to just 3, so this side I would have 3 radical 3. And then I'm going to have a plus. If I break down this, I'm going to have 25 and radical 3. Radical 3 doesn't break down, but 25 breaks down to 5, so this would be 5 radical 3. This is a radical 3, this is a radical 3. I can combine these. 3 plus 5 makes a final answer of 8 radical 3. If you were to find the square root of 27 as a decimal number and add the square root of 75 as a decimal, you would get the exact same decimal as if you did radical 3 and multiplied your answer by 8. But it'd be easier to work with just this than needed to combine both of these as individual pieces. Next one, when I look to simplify this, this number out front means I'm going to multiply anything that comes out as a perfect square. So I'm going to break this down, and remember, this is minus here, so make sure that you keep that there. I'm going to draw my separation line here. This is going to break down to radical 4 and radical 5. I'm not worried about this 2 yet. This 4 turns into a perfect square of 2 radical 5. I still have this first 2 showing up on the outside. That's just going to drop down here and is going to be a multiplication problem. So 2 times 2 would just make 4 radical 5. If you pull a number out and you have a lead coefficient already, multiply them together, because this actually means multiplication. 180, if I were to break that apart, that's going to be 36 and 5. And I went through and did, to save time, I went through and used a calculator beforehand for these. I'm expecting you to use a calculator and that list of perfect squares to do this. This is going to end up being 6 radical 5, and there wasn't a number outside, but remember it was minus. So I put 4 radical 5 minus 6 radical 5, and my answer to this is going to be negative 2 radical 5. Next one over here, I can break down 27 as 9 and 3. The other thing that's nice is that because I'm giving you smaller numbers, sometimes you can copy one of these from somewhere else. So I know that this is going to be 3 radical 3, but I still have this negative 6 out front. So when I multiply that, I get negative 18 radical 3. On this side, when I break down 12, I get 4 and 3. 4 breaks down to 2. So that's going to be 10 times 2, and then this radical 3 at the end. So that's going to be plus 20 radical 3. I can add these because they have the same radical. Negative 18 plus positive 20 would make 2 radical 3. Next problem over here. Because these are just a single b, I can't break those down because they're technically b to the first power. You're not going to have any variables in your homework today. For the most part, it's just going to be a single b. You're not going to have to break the exponent down as well. I'm sorry, break down the variable. So for this problem, I just want to work with the 45. That's going to be radical 9 and radical 5. I would keep the b with the 5 because we know that 5 isn't going to break down any farther. We might as well keep b because we know it's not going to break down. This becomes a 3. When I bring this 2 down, I have 2 times 3 and then a radical 5b. 2 times 3 is going to be 6 radical 5. And then this is that letter b that keeps dropping down. It's not 56. Next one, 125. That's going to be 25 and 5. And if you notice, I now have a 5b showing up over here again because I can drop this b down like I did over here. This is going to make 5 times positive 3, which comes down. So that's going to make plus 15 radical 5b. So my final answer to this is going to be 21 radical 5b. And remember, I'm just pulling the symbol here and dropping it down and adding the outside numbers like we did up top. These last problems, if you notice, they just have 3 terms. That's the only thing that's different. But if you notice, the numbers are also a little bit smaller. I tried to do the same thing on your homework today. If you have 3 things to add together, I tried to make the numbers smaller. For the first one, 25 is a perfect square. So I can just make this 5c, because 5 radical c, sorry. 25 is a perfect square, so that answer can come outside those radical symbol, but c to the first can't. This is also a perfect square of 4 times 4, so that's 4 radical c. Next one, 8, I can break that down to, and I'm going to draw a little line here to break it apart. That's going to be radical 4 times radical 2c. 4 breaks down as a perfect square as 2 radical 2c. I can combine these two because they're just c. I can't combine this third one because it's 2c. 5 plus 4 makes 9 radical c, and then I just add this plus 2 radical 2c at the end. Like I said at the beginning of the notes, sometimes you're not going to be able to combine all of these. You might have 2 radicals left over at the end, and that's okay. It's one of the reasons I'm making this multiple choices. Hopefully, if you're not 100% sure, you start to see one of the multiple choice answers show up. Also, if you notice, this isn't requiring as much work as you might think. I am expecting you to show your work like I am. Next one, when I break down 54, that's going to be radical 9 and radical 6x. And I'm also going to have that 6 outside of it. 9 breaks down to 3 exactly. So this turns into 18 radical 6x. 24 is going to break down to 4 times 6. And if you want to draw that little line here to help with your spacing, you can. Sorry that I'm writing a little bit small. I'm trying to keep things organized. Times 3 from the front. 3 times 2 radical 6x. 3 times 2 is 6, so I have plus 6 radical 6x, and it looks like I've got a pattern of at least one thing we'll be able to combine. 3 radical 6 I can't do anything with. 6 has no perfect square that goes into it. It's just going to drop down and see if I can add it to something. I can't, though, because it doesn't have an x. So I can combine these two and call this 24 radical 6x. And then I'm just going to put this plus 3 radical 6 at the end because I can't combine it. It's missing that x value. That's all that you're doing today. I was hoping these notes wouldn't take so long, but it's pretty straightforward. We are going to practice this again on Tuesday. If you have any questions or want to work through a problem, email me. We can set up a Google Meet. I will actually do a homework problem or two with you, and I can write it out and show it to you on the screen. Let me know if you need anything.